In this lesson, we will learn about logic gates. We will start with inverters and the AND gate and the Nand gate, which, as you will see, these gates are part of a latch, a 1-bit memory, and registers, which are widely used in a computer architecture or a microcontrollers architecture. And so right here in this table we have two inputs in binary code, 0 0 0 1 1 0 and 1 1. And when you have a digital circuit with two inputs, there is a possibility of having 16 different outputs, and they are here, well, we have 15 from 1 through 15 because we're not considering the output 0. And if you start seeing this table in the vertical format, I'm writing here the binary code because this is number 1, number 2, 2 plus 1, this is 3, 4, 5, 6, and so number 7, until you end up with number 15 on this area. So number 15 is the maximum, which is it doesn't have any application even when it is included here. Okay, so when you have two inputs on 0 logic and your output is 1 and with the rest is 0, that's the NOR gate. This one is just a combination, another types of combinations, but the AND gate is here in number 8, in column 8, because the output is 1 only when A and B are 1s. Okay, for the OR gate, the output is 1 only when both inputs are 0s. And this is the AND gate. So the opposite of the AND gate is the NOT AND gate, which we abbreviate as the NAND gate. And the NAND gate is the opposite of this column. And when I say the opposite, is the logic is inverted. So you have ones at the output for these combinations, but when both inputs are 1, okay, the NAND gate is 0. Okay, so it is exactly the opposite of the AND gate. Of course, there are other gates, like the OR gate. The OR gate is right here on column 14, because the OR gate gives you a 0 when both inputs are 0. But for any other combination, when you have 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1 is equal to 1 in binary code. And the opposite of the OR gate is the NOR gate, which is in column 1. So you have here this. So the output is 1 only when both inputs are 0s. Okay. And there are other gates like the exclusive OR and the inclusive OR, which are used for comparison purposes. We will see those in another lesson. Okay, so this table is a summary of all the logic gates that you can have when you have two inputs and one output. Okay, so the most basic element in digital logic is the inverter. There are inverters in different technologies, but I'm focused on CMOS technology because of the high input impedance, which is greater than 10 mega ohms, and the low output impedance, which is less than 100 ohms. So a classic integrated circuit is a 4007 CD4007, which has 3 inverters where we can make CMOS inverters where we can make different combinations. Like the one you see here is a tri-state inverter. Okay, and those inverters, of course, you can test an inverter by putting a switch here And to avoid having the switch floating and the input floating, we placed a pull-up resistor, which is called RPU, pull-up resistor. That way, when the switch is open, the pull-up resistor pulls this input to VDD, to voltage, and then you have a logic 1 right here. Because it is an inverter, the output is 0. When you press the switch, you have a 0 right here in this area. So the output is logic 1. That will turn on the LED, the light emitting diode, and there will be a current. This resistor is for limiting the current to avoid damaging the LED, because they work from 2 to 3 volts, depending on the color. So this is the classic inverter with true logic, but you can test the inverter also with negative logic. When we instead of placing the LED to ground, we put it to voltage with this polarity, because this is the anode and the cathode. So when you have a 0 here, you have a 1, which is 5 volts. And 5 volts, and the LED will have 5 volts on this side and 5 volts on the other side, so the LED will be off. So this is exactly the opposite of the previous circuit. When you press the switch, now you have a logic 1, and this will give a logic 0, and the current will flow, causing the LED to glow. And when you release the switch, what happens when the switch is released at the end or here in the beginning? The input doesn't float, because we have a pull down resistor, RPD, 10K in this case, which pulls down or grounds the input. That way it will not float. We don't want the inputs to float, because otherwise they will be generating noise and the LED will be flickering, and that's very common in CMOS technology. And these inputs might be affected by electrostatic charge. So if you don't put a pull down resistor or pull up, when you approach your hand, because of the electrostatic charge that you have in your body, the inputs will be charged, will be receiving a voltage, and it will not work well. So we don't want inputs to float. They always have to be grounded, okay, or go into voltage with a pull-up resistor, okay. And now this is the Nand gate. When you have a Nand gate, this is the truth table, okay. So you have, when both inputs are different, 0, 0, 0, 1, 0, 0, 1, you have an output equal to 1. When they are 1, the output is 0. So this is a way to test it, okay. And you can place pull down resistors on pin 1 and pin 2. You want to use Nand gate as an inverter, you have to tie both inputs together, and then the output will be the opposite. So you have an inverter, because you are only using this case. When both inputs are 0, the output is 1. When both inputs are 1, the output is 0. That's how it works. Now you want to have the AND gate, you can also add an inverter right here. So the output will be AB. So the output will be only 1 when both inputs are 1. So in this case, I'm using the Nand gate CD4011, but you can use any other type, like the 4093 or 74HC1382. Okay. Now, this is how you test a gate. In this case, the 4093. Right here, you see the gate is right here, and this is the output. These are the inputs and the output. So the inputs are controlled by these switches, and we don't want the switches to flow. In this case, we have a 33 and yellow, so we have a 330K pull down resistors. Okay, and that way they never float. And the switches, the other side of the switches go to voltage, the red line. So when the switches are open, you have zeros. When you press the switch, you apply a 1 to one of these input. The output, now you can see it is connected with a red, brown, a 220 ohm resistor to the LED, and that way you control it. You can test it. The inputs we're not using, like the Nand gates on the other side, you have to ground the unused pins, input pins. Never ground an output pin, or you will have a short circuit, it'll get damaged. These capacitors are bypass capacitors. They are used to reduce electrical noise from the gate. Okay, I will continue with other gates. Let me see, let's finish this video with the 4093. So the 4093, this is how the gates are in the chip. You see, the outputs are facing each other. Okay, so you have two inputs, one output, two inputs, pins 5 and 6, and the output is on 4. The voltage is on pin 14 and pin 7, because every chip requires a power voltage. So this voltage, this is ground. And so you can test every single gate. You can make a NOR gate, like in this case, and you can see it. You can use Boolean algebra to test it. Okay, so and now when you want to have the AND gate, as I said before, you put an inverter on the output, and when you have the OR gate, you can do these connections and you can test it. Also, for the classic AND gate is a CD4081. This is the pin out is 1, 2, and pin 3 is the output. So you can test it this way. When both inputs are 0, 0, 1, 1, 0, the output is 0. When you test it, when you apply 1 and 1 to inputs A and B, the output it's a 1 right here. Okay, and so this is how you test the AND gate. You want to make a 3-input AND gate, you put it in cascade. So now you have A, B, and the output goes to this AND gate, and the other output here, pin 6, will be your input C. So you have 3 inputs, and the output will be 1 only when A and B and C are 1s. So this is a gate called all or nothing. Only when the 3 inputs are 1, your output is 1. Okay, and why I'm using these red columns? Because right here, if you place, you want the LED, the output LED, to work in opposite logic, on inverted logic. You might disconnect it from ground and put it to voltage. If you connect this LED to voltage, you will have the opposite function. So and you will get an OR gate just by putting the LED to voltage. And you want to have in this case it's a 2-input OR gate, but if you want to have a 3-input OR gate, you have to put this LED to voltage, and you will also have a 3-input OR gate. Okay, that's all for this lesson, and I will continue with more gates in the next video. Thank you.